Okay, so after our brief detour, remember what we've done so far is we talked about models and how they connect to the database. We showed how you actually create the table in the database. And by the way, now you see how these two pieces go together. A migration will create the table, and the table will have certain columns for the different attributes. And that's how ActiveRecord knows at runtime what attributes you can dereference on a model, right? It's basically the column names. It essentially asks the database, tell me what columns are available in this table, and those become the getters and the setters that are available on your Ruby models. So we'll talk a little bit more now about ActiveRecord and some of the facilities for doing the other operations. We saw of the 4 CRUD operations, we saw C for create, and now we're going to do reading, updating, and deleting. So how do you find things in the database? Well, there's a class method that inherits from ActiveRecord base called where. Not surprisingly, it's meant to mimic the fact that the where keyword exists in SQL. And it lets you select things based on attributes. So I can select a movie where its rating matches a string. I can also more effectively write more complex conditions where I substitute symbols of my choosing, right? And these can be any symbols I want. And then I provide a hash that maps those symbols to the values that I want to match. So sometimes it's more clear to write a more complex query in this way because it makes clear what the intent of the query is, right? I have some cutoff in mind. I have some rating in mind. And I'm going to separately specify what the values of those are. So this is another option for how to do it. This is a really bad idea. It's got security implications that we're going to see later in the course. But in general, anytime that you're embedding a string into a query, you had better trust that string. If that string in any way was ever touched by a user, you must immediately assume the user is evil, or at best possibly incompetent, and that just jamming the string into a query like this could result in a query that is either malformed or evilly formed, which is actually much worse. So the reason to use things like this symbol interpolation is, as you might expect, there's extra machinery in Rails that will go out of its way after the substitution is done to make sure that you either end up with a legal statement or at least end up with a statement that is not malicious. There's a lot of standard tricks that evil users try that is exactly aimed at people who write code like this, and Rails has mechanisms that will circumvent most of those if only you choose to use them. A non-obvious thing about this, though, is that you can chain these things together. So for example, I can initially say, I'm going to define kitty to be movies where the rating is G. And you might ask, well, what's the result of, when this is executed in Rails, what is the result of doing this? What you would think is that the result is something like a collection of movies that have been extracted from the database. But that's actually not quite true. The result is an object that, if you ever dereference it, will cause the database query to happen. It gets evaluated lazily. So that means that I can now say, there's also old kids films, and those are kiddie films where the release date is, let's say earlier than 30 years ago. So what's the impact of these two statements? Well, if query evaluation were eager, or if it were immediate, in other words, if the act of doing movie where actually made a database query happen, then the code that I've shown here would result in 2 queries, one for each of the wheres. But in fact, the code that I've shown here doesn't do any queries at all. Now, at some point, the semantics of where is that it's supposed to return something that quacks like a collection. Remember the Ruby concept of quacking like something? It means it doesn't really matter if you're a collection. You just need to do the things that collections do. What do we know that collections do? Well, one thing collections do is they respond to each. They can enumerate themselves. So what's actually happening here, so that you understand what's going on under the hood, is at some point later on in the code, presumably we're going to say something like oldkidfilms.each do something, right? We're going to go through the collection and do something with each element. And that's the time the query happens. Only the time we actually try to get the result is the time the query happens. So a consequence of that is you can actually build up extremely sophisticated queries by chaining together a lot of different conditions. And Rails has a fairly sophisticated optimizer that will generate good SQL. And at the end of the day, only when you try to actually ask for the value of one of those objects, that's when the query happens and not before. So it's a very nice feature, and it's a part of ActiveRecord called ActiveRelation. It's basically a relational algebra engine that's built in. What other ways can you read stuff? Well, there's a collection of methods that begin with find. The simplest version is if you happen to know the primary key of something, and when we talk about controllers shortly, we'll show some examples where you actually do know the primary key. So you can just look up something by its primary key, as long as you're willing to risk an exception if you got it wrong and it's not found. You could also just say find by ID, remembering that ID happens to be the column name that Rails uses for the primary key, which is more friendly in that it just returns nil rather than throwing an exception if that ID doesn't exist in the movies table. But the more interesting one is attribute-based finders. Remembering that we set up our movies table to have title and rating, for example, we could say find all movies by rating. or find by rating a single or the first movie that matches this condition, find by rating bang, which, as you've no doubt figured out by now, will throw an exception. And you're probably already a step ahead of me and thinking, aha, I know just how that works. That code doesn't exist in any file. If you went to look for find by rating across all of the source code in your app, you would never find it. Because, of course, this is being handled by method missing. Right? And you already saw an example of this. Right? So what's the rule here? You could probably write this yourself. If you're trying to call a method find by something, and if that something happens to match the attribute name of one of the columns in your table, then it gets converted into a SQL query basically using something like the where conditions. And in fact, in case you were wondering, you can in fact say find by rating and title, find by release date and something. And then the rule is if it's find by X and Y and Z, and they're all separated by ands and underscores, and they all match attribute names, then method missing will do its thing. So again, a nice example of allowing you to do a bunch of common cases. You sort of get them for free. And it's not like this code exists somewhere and it's not being used, right? Because it's method missing, this only happens if you actually try to use this feature. So it's not like you've got a bunch of functions sitting around that you're not using. How about updating stuff? There's two ways to do it. Suppose we have already used one of the finders to grab an instance of a movie from the database. One thing we could do is we could modify the attributes in place, and then we can save the object. And remember, the big difference here is between we have an in-memory copy and we have a database copy, right? Those copies are distinct, and what ActiveRecord does is give us mechanisms to keep them in sync, to tie them together. So just because we've changed the release date in our in-memory copy, to update the database's copy, we have to explicitly save the object out again. We could also combine, there's a call update attributes that lets you essentially pass a hash of attributes and their new values, and it operates atomically. So if you try to update a bunch of attributes at once, either they all get updated correctly or none of them do. So you could think of it as being transactional in that way. And by the way, one of the a nice structural thing about ActiveRecord that we'll see is there's many different ActiveRecord calls that can modify the database, but at the end of the day, they all end up funneling through a single point called save. So there's a way that Rails allows you to do extra validation checks before writing something to the database to make sure that you never write invalid data for some reason. And you only have to put that check in one place, because all of the other calls that modify the database eventually funnel through there. So we'll talk about that when we talk about the more advanced Rails topics. Deleting is straightforward. What might be interesting if you haven't seen it before in Rails is that it's an instance method. So you first have to be able to name the object, and then you tell it to destroy itself. You could also write raw SQL queries to do this, but there's actually a very good reason why you do this. There is, in fact, a method called delete, which really just maps to what you would do in raw SQL. The reason to call destroy and the reason to call it as an instance method is, again, suppose, again, we've got the Ruby world and we've got the database world, right? In the database world, deleting is simple. You vaporize the row, the database is done with it, like it never existed. But it may very well be the case that in the world of your application, life is more complicated. For example, suppose I have movies and reviews, and suppose I delete a movie. Well, at that point, any reviews that depended on that movie have nothing to connect to anymore. So in terms of my app logic, there may be consequences to destroying an object, and I want to make sure that whenever the object is destroyed, I have the chance to sort of clean up other state. So as we'll see, destroy allows you to tie other callbacks so that when an object is destroyed, you can do various other things. It's a little bit like finalize in Java, if you want to think of it that way, right? So this is the reason that perhaps counterintuitively, destroy is an instance method. You find the thing you want to destroy, and then you tell it to destroy itself. Ruby helpfully gives us the technology so that once we've actually called destroy on an object, so now again, right, the database world, the Ruby world, now the database's version of the object is gone, but we've still got M. We've got this data structure in Ruby. What would prevent us from trying to modify the attributes, even though we know we'll never be able to save it again because we deleted it from the database? Well, as it turns out, this will fail, because once you've destroyed an object from the database, Rails will change the way that the title setter works to basically say, no, sorry, you can't do that. So once you've destroyed an object, you might think that the setters still work, but they'll actually raise exceptions. The object will have been frozen. And again, this works because all access to the internal state of an object is through these getters and setters, and we can modify at runtime how they behave, right? It's another example of how a language feature is used in support of an abstraction. So here's kind of what we've learned so far about ActiveRecord, which is by far the most interesting and important part of Rails. This is sort of just getting your feet wet. If you subclass from ActiveRecord base, that's how you create a model. That means that you can connect a model to the database and get built-in behaviors for doing the 4 basic CRUD operations. Because of convention over configuration, you can deduce the name of the model, the name of the database table, and the name of the code file for your model are all related by a simple set of rules. And by default, ActiveRecord will give you free getters and setters that are named after the table columns, and they all work the way you expect. In fact, they work a little better than the way you expect because, for example, different databases like MySQL versus Postgres have different internal representations for certain types like date times. Ruby has a datetime type. It has a bunch of different datetime types. So when you assign something to a model attribute that has a datetime value in the database, one of the nice things Rails does is convert back and forth between the representations. So if the database has it stored as a datetime, it will parse whatever the database's representation of datetime is, and what you get handed back is a Ruby datetime object, which has all the great datetime behaviors. And conversely, when you set a new value for it, you can set the value to anything that Ruby thinks is a reasonable representation of a date and a time, and Rails will make sure that it gets serialized correctly for whichever flavor of database you're using. Right? So the getters and setters actually do quite a bit. And remember, the thing that kind of ties all this together is you've got an object in a memory, you've got a row in the database where you're persisting that object. Those two things are distinct. Right? ActiveRecord is an abstraction that tries to keep them close together, but it is not a perfect abstraction, and there's going to be times when you see it leak. One of them is, like we said, when you try to destroy an object, you still have the in-memory copy. You can't make the in-memory copy just go away, but the best that you can do in a leaky abstraction is it'll prevent you from trying to make changes to the in-memory copy. It's kind of a rude reminder that, hey, you deleted the object. Right? So